Okay, so we have another example on Cauchy integral theorem. Example number 2, integration of 4 minus 3z upon z minus 1 z minus 2. So z will be there. Let me draw a line. I hope it will be visible. Okay, so and one more thing here, mod of z is equal to 1.5. It is given. Okay, so here as we can see that mod of z means it is equal to r, means radius is 1.5. If radius is 1.5, then it is z0, z is equal to 1. Okay, let's first of all let's find the order of zeros. So it is 0, 1, 2. So remember, these 2 points lie inside the circle, but this 2 does not lie inside the circle because circle radius is 1.5. It is 1.5. Okay, so this does not lie inside the circle. So what we will do that we will be able to find value in this 2 order of zeros, not this one. Okay, so let's do the process. So what we will do, firstly we will do partial differentiation, partial fraction 1 upon z minus 1 and z minus 2 is equal to 1 upon z plus 1 upon z minus 1 plus 1 upon z minus 2. Now we can find, here is 1, here is A, this is B, and this is C. Okay, this is something how we write. So now we have to put z is equal to 0 in these two. So here will be 0 minus 1 minus 1, 0 minus 2, so minus 2, minus 1 plus 2, so 1 by 2. A is equal to 1 by 2. I'm just using shortcut, but I am doing now I will put z is equal to 1, not in this one but this and this one. So z is equal to 1 means 1 into 1 minus 2, so minus 1. 1 into minus 1 is minus 1, so 1 upon minus 1 is minus 1. So B is equal to minus 1. And now C is equal to, z is equal to 2, so I will put here, not here, here. So 2 into 2 minus 1 is 1, so 1 upon 2 into 1, so 1 by 2. C is 1 by 2. Okay, so these are values. Now let me put it. Also we can let f of z is equal to 4 minus 3z. Integration of f of z upon integration of f of z upon z f of z. Yeah, so f of z, this will be outside. Now we have to put, हमें ये रखना है और इसकी वैल्यू भी इसी पे रखनी है. ए की वैल्यू क्या है 1/2, बी की वैल्यू क्या है ऐसे. सो 1/2 z was there and now minus 1, so minus 1 upon z minus 1, and here will be plus 1 by 2 and z minus 2. Okay, yeah, so now Now simply just we have to integrate, like 1 by 2 we will take outside common, so 1 by 2 integration of fz upon z minus integration, here will be also dz, minus integration 1 upon z minus 1 dz plus 1 upon 2 outside, and f of z also come here, f of z upon z minus 2 dz also. But remember one thing, that here is z, or I can write here is nothing, then I can write z minus 0, doesn't matters. So here z minus 0. Now applying Cauchy formula. So what was Cauchy formula? That 1 upon 2 into 2 pi f of 0, this 0, right? And same with 2 pi iota also, 2 pi iota f of 1, right? Plus 1 by 2 pi iota f of 2. So as we can see here, f of z is equal to what is f of z? 4 minus 3z. So f of 0 is equal to 4 minus 0 equal to 4, and f of 1 is equal to 4 minus 3 is equal to 1, and f of 2 equal to 4 minus 6 is equal to minus 2. So we do not need to find the value of f of 2, because we know that this point lies outside the circle. That's why this value will be 0. So here, what is the value? 2 to 2 cancel, so pi f, and the value of 0 is 4. So 4 pi I. It will be 4 pi I minus 2 pi f of 1. F of 1 is 1. So 1. So 2 pi I only. 2 pi I. So value will be 2 pi I. Okay. So this was our solution final. Basically this was let me summarize it. This was our question. So what I did, फर्स्ट ऑफ ऑल हमें देखना होता है कि क्या पॉइंट सर्कल के अंदर लाई कर रहे हैं. जैसे कि हमने देखा z इज इक्वल टू 0, z इज इक्वल टू 1, या बोथ पॉइंट्स आर लाइज इनसाइड द सर्कल, बट z इज इक्वल टू 2 डज नॉट लाई इनसाइड द सर्कल. Okay, does not lie inside the circle. So what I did, then I did partial fraction, and I have found the value of a, b and c. Then after I put it on this and just integrate it. Simple. Okay, now let's see the second example. E to the power 2z upon z plus 1. E to the power 2z upon z plus 1 to the power 4 dz, and mod of z is given is equal to 2. And mod of z is given is equal to 2, and here the 0 point will be z is equal to minus 1. It means it lies inside the circle. Let me just discuss some more concept. यहाँ पे याद रखना है, यहाँ पे z is equal to 2 means circle will be something like this. So like z is equal to 2 means, suppose this is 1, this is 2, means minus 2 points also will be included, minus 2 and 2, minus 2 points, it means z is equal to minus 1, means this point will lie here or anywhere. It is inside the circle. That's why I was just trying to explain you this only. So now what can we do? So now here, as we can see, here is power 2. We cannot factorize it like we need something z minus 1, z plus 2 and z plus 3 so that we can define it. But as I told you that जैसे जैसे क्वेश्चन आते जाएंगे I'll discuss you from many concepts. So here is another concept. If the power is highest, then how we calculate is if fz upon z minus a to the power n plus 1 dz is equal to 2 pi I f to the power n a upon n factorial. Remember this. Now here n plus 1 means if n plus 1 we have given it is 4, means n is equal to 3. Remember, so we will put here 3. Here also fn means how many times we have to differentiate. So here is 3, then we need to differentiate 3 times. We know that f of z is given e to the power 2z, but it will be f dash z, or we can also like this, then f of a equal to this. So f of a is equal to e to the power 2z, means 2 will be here, so e to the power 2z, 2 will be here, e to the power 2z as it is. And f double dash of a is equal to 2 to the 4 e to the power 2z, and f triple dash is equal to 4 to the 8 e to the power 2z. Okay, so sorry, triple dash, there is triple dash differentiation. Now just I am putting whole value in this formula. So f of z as it is upon z plus 1 to the power 4 dz, f of z plus 1 to the power 4 dz 2 pi I f triple dash, and we know that z is equal to minus 1, right? So here we will put minus 1. So minus 1 upon n factorial is n is 3 factorial. So remember, here we have to find f triple dash minus 1. So f triple dash minus 1 is 8e to the power minus 2, 8e to the power minus 2. To the power minus 2. So let's put it here. So 3 factorial means 3 into 2, 6, right? And this to this can be cancelled. So pi I can put here value pi I into 8e to the power 2z upon 3 and now I can put the value of z, this, which is the final answer will be pi I by 3 into 8e to the power minus 2. Okay, so this will be our final answer. So यहाँ पे हमें कुछ नया सीखने को क्या मिला, which was this one. Like अगर पावर कुछ ज़्यादा है like 4, 5, 6, then we use this formula f of z upon z minus a n to the power n plus 1 dz is equal to 2 pi if. 2 pi if n a n factorial. So n plus 1 is equal to 4, n is equal to 3, f of z is equal to this, f dash this, and then this, then this. Finally I put a value, I have this final answer. Okay, so now let's move on to the next example. First of all, let me draw the line. Okay, so example number 4. Example number 4 says that sin z upon z minus pi by 6 square dz, also given mod of z is equal to 1. So now here we have to think that it is z is equal to minus pi by 4, means z is equal to pi by 6, and this is given. So is this line inside the circle? Then we will use same formula. What was formula? Formula was f of z upon z minus a n plus 1 dz is equal to 2 pi iota f of n a upon n factorial. So here n plus 1 is equal to 2, n is equal to 1. So like we have to find derivative minimum one time, because here n is equal to 1. I'll put here f dash 1. So f of z as given sin z. Let so f dash z is sine, differentiation of sine is cos z simply. Okay, so now let's put on the formula. So I'm putting on this, it will be 2 pi I, and f dash z is cos z. So I'm just putting it directly, 2 pi I cos z upon 1 factorial. So remember here f of z is this, and what will be f of pi by 6, because here z is equal to pi by 6. So f of pi by 6, we know pi by 6 is 180 upon 6 is 30. So cos 30 is I think root 3 by 2. So cos 30 is root 3 by 2. So 2 pi I into root 3 by 2. This to this cancel. So here will be root 3 pi I. This will be our answer. It's very simple. Simply when using this formula, it becomes very simple. Okay, so remember this formula. Okay, so now we will discuss our new concept, that is Cauchy residue theorem. Residue theorem. Okay, so first of all, let's write the statement. What is the Cauchy residue theorem? Statement is, if fz is an analytic function inside and a simple closed, if fz is analytic, I have already told you that what is analytic function. Like Cauchy CR equation should be satisfied, that is analytic function like du by the partial differentiation of u and with respect to dx, and partial differentiation of v with respect to dy, and cm with opposite sign. I have told you it. So analytic function inside and analytic function inside and and then a simple closed and a simple closed simple closed loop, or you can say container. Okay, except at finite number, except at finite number of poles, except at finite number of poles. What are that poles? Singular poles. Now I will also discuss about singularity, non-singularity, isolated singularity, non-isolated singularity. I will discuss about all of that. But before this, it should become Z1, Z2, Z1, Z2, Z3, and Z4, Zn. Derivation of this is f of z dz is equal to 2 pi iota r1 plus r2 plus r3 plus r4 plus rn. Okay, so basically हमें क्या करना होता है कॉची रेसिड्यू थ्योरम में? सिंपली वी हैव टू जस्ट फाइंड द इंटीग्रेशन. सिंपली 2 पाई आई लिख करके हमें जितनी भी रेसिड्यू निकालनी है उनका ऐड कर देना है बस. दैट विल बी आवर फाइनल आंसर. So now some important points to remember. First, residue theorem, simple pole at residue theorem, simple point, simple pole at z is equal to 1, z is equal to a. So residue f of a, limit z tends to a, z minus a, f of z. Okay, so residue at pole of order n. Now at point A था, now residue at pole of order n. So at z is equal to n is equal to 1 upon n minus 1 factorial d n minus 1 upon d z n minus 1 z minus a to the power n f of z. Now third is residue. These are some formulas which you have to remember while finding the solution of these type questions. So residue at infinity, simple, r is equal to limit z tends to infinity z of f of z. Okay, so now let's discuss about the example on this Cauchy residue theorem. Find the order of each pole. Find the order of each pole, order of each pole order of each pole and residue H and residue as it of so 1 minus 2z z minus 1 z minus 2. Okay, so here as we can see that we have given this. So now first of all we have to find the pole, then after we can find order. Firstly we have to find pole, then after we can find order. Okay, so here we can see that pole is z is equal to 0, here is nothing, so and z is equal to 1 and z is equal to 2. So these are simple poles. Now what we have to find is we have to find order. Okay, so what we will do here, r1 is first, so simply we will put here limit like r1. For r1 we will put in here, this is r1, this is r2, we will put this, it will be r3. So r1 limit z tends to 0, so here z minus 0 only and 1 minus 2z upon z minus 0, because here is nothing, so मैं z minus 0 भी लिख सकता हूँ, doesn't matter. Z minus 1 and z minus 2, this to this get cancel and z minus 1 z minus 2, here z tends to 0, so we will put here 0. 2 into 0 is 0 and 0 minus 1 0 minus 2, so minus 1 into minus 2 is 2 only and 1 upon 2, so r1 is equal to 1 upon 2 and r2. Now limit z tends to r2 is 1, z tends to 1, so I'll put here this is 1, so z minus 1 1 minus 2z as it is upon z minus 1 and z minus 2. This z minus 1 to z minus 1 cancel. Now z tends to 1, so we will put the value 1 in place of z, just 2z only. So 1 minus 2 into 1 minus 2 into 1, so minus 1 and upon 1 minus 2, 1 minus 2 is minus 1, so minus 1 only, so it is minus 1 cancel, so r2 is equal to 1. Now r3 limit, we know that r3 is 2, limit z tends to 2, so z minus 2 1 minus 2z upon z minus 1 upon z minus 2, z minus 2 cancel and here z tends to 2, 1 minus 2 into 2 4 minus 3 upon 2 minus 1, 2 minus 1 is 2 into 1, so 2, so minus 3 by 2. What will be here? Here will be minus 3 by 2, so r3 is minus 3 by 2. r3 is minus 3 by 2, this is r3. And what was the formula? Formula was that we have to put simple 2 pi r then r1 plus r2. So according to formula, now according to formula so integration of f z dz is equal to 2 pi I. Okay, 2 pi I r1 is This is R1. So here R1 is 1 by 2, R2 is 1, R3 is minus 3 by 2. So 1 plus 1 by 2 minus 3 by 2. So we will solve it, then we will get 2 plus 1 minus 3 upon 2. 3 minus 3 upon 2. 3 minus 0, then 0 means 0 we will get. Means order of this is 0. Okay, so now we will discuss about Taylor series. So Taylor series, first of all let's discuss the theorem. What Taylor series says is, if a function fz is analytic inside, if a function fz is analytic, fz is analytic inside, fz is analytic inside a circle C, inside a circle C with center at z is equal to a, with center at z is equal to a, then it can be expanded in series. Then it can be expanded in series. So let me repeat it. What is he saying? If a function fz is analytic, I have told you that which type of functions are analytic inside a circle C. Means if a function, these are some points, if these are defined, these are points are inside the circle, then z is equal to it can be expanded. अगर circle inside, अगर points is inside a circle, so हम इसे expand कर सकते हैं something like this. F of z is equal to f of a plus z minus a upon 1 factorial, f dash a plus z minus a square upon 2 factorial, f double dash a same with z minus a cube upon 3 factorial, f triple dash a plus z minus a power 4 upon 4 factorial, f 4 times dash a. Most of the times we just find triple derivative only, and plus goes on z minus a power n f triple dash n upon n factorial. Okay, so most of the time just we find triple dash only. Now let's see the example on Taylor series. Expand 1 upon z plus 1 about z is equal to 1, z is equal to 1 in Taylor series, yeah. So this will be given that here are two more series. So in question he will be saying that you have to expand in Taylor series, or you have to expand in residue series, or you have to explain or one more series. So this will be given. Okay, so now it is final that we have to expand in Taylor series. For Taylor series, what we have to do is, first of all we have to find the derivative, like f dash, f double dash, f triple dash. So let f z is equal to 1 upon z plus 1, right? So what will be f dash z? What will be f dash z? So we know that z minus 1 will be percent z plus 1 to the power minus 1. It will be differentiating, then minus 1 upon z plus 1 square. Okay, and what will be f triple dash z? Sorry, f double dash z. It will be minus 2 so minus 2 upon z plus 1 cube. Okay, and what will be f triple dash z? It will be minus 6 upon z plus 1 4. Okay, so this is all. So now we have to given that z is equal to 1. Okay, so f of 1 is equal to 1 upon 1 plus 1, which is 1 by 2. F of 1 is equal to minus 1 upon 1 plus 1 square, means 2 square is 4, so minus 1 by 4. F double dash 1 is equal to minus 2 upon 1 plus 1 2 का cube is 8, so this is minus 1 by 4. Minus 1 by 4. And same with f triple dash 1, so is equal to minus 6 upon 1 plus 1 to 4, so 16. So this will be 3 by 8, minus 3 by 8. Okay. Yeah, so now let's put on the series. Now putting all values in Taylor series. Okay, so what is Taylor series? This is Taylor series. So f z is equal to f of a. What is f of a? F of a, we can also write f of z, doesn't matter. So f of a is 1 by 2 minus 1 by 2, and f of a is 1 by 2, which I have put in. Now z minus a, f dash a is minus 1 by 4, so minus 1 by 4 I have put in it, minus 1 by 4, and z minus a is 1, so z minus 1 upon 1 factorial, so doesn't need to write it because 1 factorial is always 1, and anything divided by 1 is always 1. Anything is divided by 1 comes that value only. So now this one, z minus a square, so minus again 1 upon minus 3 upon 8, right? 3 upon 8, and sorry, minus 1 upon 4, minus, here will be square, right? Here will be square, then 2 will be also here. Firstly f dash 1, no, so z minus 1, so no need to write it. I'm just getting a little bit confused. So here will be what? Here will be minus 1 by 4, and z minus 1 square upon 2, and minus 3 by 8, z minus 1 cube upon 3 into 2. That's 3 factorial, right? Just this only. And as we can see that 3 to 3 cancel, and this is as it is. So now we have to just expand it. So what will be z plus 1 square. I do not need to expand it, simply I can write fz is equal to, is anything is which I can take common. So yeah, so 1 by 2 I can take common, so 1 by 2 I can take common, so it will be 1 minus 1 by 2 z minus 1 by 2, So here will be 4, here will be z minus 1 square minus z minus 1 cube upon 8. Okay, so I can also take, no, I cannot take anything common right now, so this will be our expansion according Taylor series. Okay, yeah. So what I did is, basically we have to just apply this formula only, and I just, most of the time हम 3 बार ही differentiation करते हैं. So this, we have found this, and I have put it all values in Taylor series, and then simply we get the answer. Yeah, so one more thing which I want to discuss, that this was the first method of Taylor expansion which I have discussed. Or here is also a second method which is more easier to solve, and less use of brain. So I want to discuss that concept also. So most of the time what will happen, that if there is some bigger value, then we have to differentiate many times, then we will put value, and you see that I get confused here, so you may also get confused here that this value I have to put or not. That's why let's discuss the second method of Taylor expansion. So example will be same as f of z is equal to 1 upon z plus 1. Okay, example is same. So okay, let me think. Example is just same. So what we do here is, we know that z is equal to minus 1. Z is equal to minus 1. Z is equal to minus 1. So let here z minus 1, sorry, z plus 1 is equal to t. So z is equal to t minus 1, right? So I'm just putting in place of z t minus 1. So f of t minus 1 upon t minus 1 plus 1. So this will cancel each other. Yes, sorry, just see here. In question we have given z is equal to 1. Okay, it is given z is equal to 1, not 1. So here given z is equal to 1. So z is equal to 1 means z minus 1 is equal to t we have let. So z is equal to t plus 1. Got it? T plus 1. So I am replacing here by t plus 1. So what will be, this will not cut each other. So what will be t 1 upon t plus 2. Got it? 1 upon t plus 2. So what we will do right now, f of t is equal to 1 upon t plus 2. So for this we need to take common. 1 upon 2 we have taken common, then 1 plus t by 2, right? So, or I can also write it, f of t 1 upon 2, 1 plus t by 2 to the power minus 1. Yeah. So now one thing which I want to recall all of you, so here we know that 1 plus x to the power minus 1, it can be written as, it is binomial, some binomial concept, okay? So it can be written as 1 plus x square plus x cube, that is plus x to the power n, and same with m1 minus x to power minus 1. This can be written as 1 minus if here is plus, then this sign will be alternative. Sign will be alternative. Okay, sign will be alternative. Here it is minus, so it will be written as 1 plus x minus x square, 1 plus x square plus x cube that is plus xn. Okay, so now what I will do, I'll just use this one. I'll use this one because this is as given. So 1 by 2, now just using binomial expansion. So 1 minus x means t by 2 as it is, plus t square means t square by 4, minus t cube means t cube by 8, plus ऐसे चलता जाएगा. And I can also write, we know that t is equal to what I have let, t is equal to z minus 1. T is equal to z minus 1. So I'll put it in place of t. So 1 by 2, 1 minus z minus 1 upon 2 plus z minus 1 square upon 4 plus minus z minus 1 cube upon 8. And I can also take, but this is our final expansion. So है short, it is kind of short method. So I called it short because simply just we have to given z is equal to 1, then I have just let the value and I have just replaced it. Simply we have to use a binomial theorem, just take care of it. Binomial, these are two formulas. Then after we will expand, we will put according this, and hardly it will take 50 seconds to calculate it. It will take minimum 2 minutes. That's why I thought to discuss about this second method. Okay, now here is another example on Taylor series. So I'll use short method only, although I can solve from that method also. So find, if example number 3, second on it, find the Taylor series. Find the Taylor series. Find the Taylor series. Expansion of the function. Of two complex variable. So the complex variable is given f of z is equal to 1 upon z minus 1 and z minus 3. Okay, so ये भी दिया है कि z is equal to 4. So now simple, I'm using second method, that z is equal to 4 is given, means z minus 4 is equal to t. So replacing it by z minus 4, so f of t is equal to 1 upon means z is equal to t plus 4. If I will put here t plus 4 minus 1 means t plus 3, right? Upon t plus 4 minus 3 is t plus 1. Okay, so now we have stacked here, because यहाँ पे तो सिंपली हमें एक्सपेंशन यूज़ कर लिया था हमने, बट यहाँ पे हम इसलिए नहीं कर सकते, जस्ट बिकॉज we have to do partial fraction. Okay, so partial fraction. So it's 1 upon t plus 3 upon t plus 1. So it is a upon t plus 3 plus b upon t plus 1. So t is equal to minus 3. I'll put here t is equal to minus 3 plus 1 minus 2. So a is equal to minus 1 by 2. So b is equal to t is equal to minus 1. So I'll put here minus 1. So minus 1 plus 3 is 1 by 2. b is equal to 1 by 2. Okay. So I'll put here minus 1 by 2. Sorry, minus 1 upon 2 t plus 3 and plus 1 upon 2 t plus 1. Okay. So now what we have to do is we have to make here 1. Here is already 1, but here is not. So what I will do, I will take common 3. So f of t is equal to minus 1 upon, I'm taking common 3, so 3 2 is 6. So here will be 1 plus t by 3. Okay, and plus 1 by 2. Here do not need to do anything, t plus 1 already. So now I'll move it towards upper side. Minus 1 upon 6, 1 plus t by 3 power minus 1. Okay, plus 1 upon 2 to the power t plus 1 to the power minus 1. Okay, so again I'll use binomial expansion. We'll use here binomial expansion. What is binomial expansion? 1 minus x, 1 plus x to the minus 1. It is 1 minus x plus x square minus x cube, and so on. If 1 minus x minus 1, then simply here will be all just positive. 1 plus x square plus x cube. Okay, so here just I'm putting according that. So here it is minus 1 by 6, so minus 1 by 6 outside, it is 1 plus t by 3, means all alternative signs. So 1 minus t by 3 plus t square by 9 plus t cube by 27. Just it will go on, plus 1 by 2, 1 plus t, like here is 1 only, so 1 plus t square plus t cube. Okay, so this is our answer. This is our expansion of Taylor series, Taylor series. या सो अगर अब हमें फर्स्ट मेथड से करना होता तो कैसे करते? सो हियर इज फर्स्ट मेथड. नो, सो इट इज या अगर हमें फर्स्ट मेथड से करना होता तो कैसे करते? सो फर्स्ट ऑफ ऑल हमें तो ट्रिपल टाइम्स, अब देखो यहीं पे देखो, अब हमें फर्स्ट मेथड करना होता तो हमें पहले इसका डिफरेंशिएशन करना होता. अब इसका आप डिफरेंशिएशन कैसे निकालोगे? जस्ट think about this. It will be very 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 complicated. Like first of all we will multiply it. Like अगर first method से जाएं तो we will multiply it by minus 3, so minus 3z minus plus 3 and plus z square minus z. So here will be minus 3z minus z minus 4z, so z square minus 4z plus 3. Okay, so now we have to differentiate is f of z f dash z is equal to 2z minus 4, and f double dash z is equal to 2, and f triple dash z is equal to 0, and here z is equal to what is given here, the z value is given, z is equal to 4. So I'll put here 4. First of all here I'll put 4, to f of z is equal to 4 चौको 16 minus 4 चौको 16 minus again 4 चौको 16 plus 16 minus 16 cancel, so here will be 3 only, and here will be 4 दूना 8 minus 4, so here will be 4, and here will be 2 only. Okay, so now Now we'll put on formula. Now formula, what was formula? So this is formula. Value Taylor series. So this formula, I'll putting all values on it. So f of a, what is f of a? F of a is 3 only. So 3, all signs are positive. So 3 plus z minus 4 upon 1 factorial, doesn't matter. So and f dash z is 4 into 4 plus now z minus 4 square upon 2 into 2 plus z minus 4 cube upon 3 into 2 into 0, because f triple dash z is 0 into 0, so this whole term will be 0. So यार इतने भी कॉम्प्लिकेटेड नहीं है फर्स्ट मेथड से, बिकॉज मैंने तो फर्स्ट मेथड कभी सॉल्व नहीं किया. मैं तो बस ऑलवेज प्रेफर सेकंड मेथड, बिकॉज मोस्ट ऑफ द वीडियोज विच यू विल वॉच इन यूट्यूब they all are solving by second method. But if we will see this, then it is also very easy, right? Okay, so now if we will open it, then 3 plus 4z minus 16 plus z square plus 16 minus 4 to the 8z, and this 2 to 2 will cancel. So this is 4z, this is minus 8z, and this is 16, this is 3. First of all, z square as it is, and now minus 8z plus 4z, so minus 4z only, and plus 16 plus 3 plus 19. So this will be our answer. This will be our expansion according first method, Taylor series. So yeah, now few concepts are remaining. So my just all pages are full. Now thinking to buy a new page. Okay, so now let's discuss about the second topic, that is Lorentz series. So first of all, let's discuss about statement. So what was the statement is, if we required to expand fz, about a point where fz is not analytic, then it can be expanded by Lorentz series. Okay, so if we require to expand fz about a point where fz is not analytic, remember here not analytic, जब हमें एनालिटिक होता था तो हम सिंपली वी कैन सॉल्व थ्रू टेलर सीरीज. अगर नॉन एनालिटिक है, नॉन एनालिटिक का मतलब क्या है कि अगर पॉइंट्स हैं वो सर्कल के अंदर लाइज नहीं कर रहे हैं, दैट इज कॉल्ड नॉन एनालिटिक. सो लेट्स डिस्कस. So let's suppose this is A, and from here to here this is R1, and from here to here this is R2. Okay, this is contour C1, or we can also loop. This is C2 and this is C1. Let's draw the line. So according to this, if fz is analytic on c1 c2, if fz is analytic on c1 and c2, annular region, annular means inside, annular region are bounded by congestic circles, are bounded by congestic circle, means this congestic circle c1 and c2 of radii, c1 and c2 of radii r1 and r2, r1 and r2, r1 and r2, r2 greater than r1, and with center at a, and with center at a, then fz a naught plus a1 z minus a plus a2 z minus a square plus this plus b upon z minus a. And the formula is an is equal to 1 upon 2 pi I integration of fw upon w minus a n plus 1 dw. This is for en, and suppose bn, then bn 1 upon 2 pi fw upon w minus a minus n plus 1 dw. Okay, so now let's see the example. Let's see example. So recently I have discussed with you these some topics like line integral in complex form, Cauchy integral theorem, mereas theorem, Cauchy integral formula, Cauchy integral formula of derivatives, analytic functions, Liouville's theorem, and this all Taylor's and Lorentz series, singularities, zeros of poles, residue theorem, evolution of integral. So now I'll see all of this, I'll search all of this in Google so that you can get more accurate information. So firstly we will discuss with line integral in complex form. Let's search line integral in complex form. Okay, as we can see, a line integral in complex form, also known as the contour in the integral. Contour integral. Okay, so a line integral is also known as contour integral. So जो मैं सबसे बार बार बोल रहा था ना, contour, I was feeling very weird while speaking this word, that's why I used loop. So remember that was contour integral. Okay, so a method integrating a complex valued function along the path in the complex plane. It's a powerful tool to complex analysis, enabling the evaluate integrals along curves and understand the properties of the analytic functions. Okay, so these are also contour are smooth and pursue a smooth curve to complex plane parameterized by a complex value. This parameterization, differential and parametric substitute into this function, multiply, derivative, integrate. So this is all. So now we will see about Now we will see about integral theorem. Integral theorem. Integral theorem. Integral theorem. Engineering mathematics. So we can see the statement is f is an analytic function holomorphic within the simply contained region, then the contour integral f z is around of the closed loop. So in the context of the engineering mathematics, the integral theorem is a powerful tool that relate the different types of the integral, often simplifying the evolution the complex integral, providing the insight the behavior of functions. Okay, so under this comes Cauchy integral theorem formula, which I have discussed with you. Okay, so this is all. Under this comes Green's theorem, Stokes theorem, which I have discussed in many times before. Okay, so now let's discuss about Mereas theorem. Mereas theorem. This function fs. So Mereas theorem concept analysis and state that if a function is continuous in a simply connected domain and the integral of the function over every closed contour within that domain is 0, then the function is analytic, homomorphic within the domain. Okay, so converse of, I have told you that it is converse of Cauchy integral theorem. Mereas theorem is often considered as the converse of the Cauchy integral theorem, so which states that the integral of the analytic function over the closed contour its domain is 0. Mereas theorem essentially provides a way to provide the function analytic showing the integral. So this is all about this. Okay, so now we will see about Liouville's theorem. Liouville's theorem. So it is Liouville's theorem. Entire function is complex that have no bounded function, a function whose magnitude fz mod of fz never exceeds this certain finite value. Okay, that's important. Foundation of other result. Liouville's theorem is a fundamental result of the complex analysis is used to prove other important theorems. Okay, so now we will see Taylor and Lorentz series. Firstly, Lorentz series. Lorentz series, a representation of complex function as a power series that includes both positive and negative power variables. Okay, include negative convergence of angular analytic. Okay, this all. Okay, yeah. So now we will search singularities. We search our singularities. So okay, there is nothing else. Singularities. That's all about. Okay, so now we will see example on Lorentz series. So example, we have given, we have to expand the series. Expand the series. Series is given f of z is equal to 1 upon z square minus 3z plus 2, and conditions. Some conditions are given. Conditions: first, mod of z lies between 0 and 1. Second, mod of z lies between 1 and 2. 1 and 2. Third, mod of z is greater than 2, and fourth one is z plus 1 less than 2 less than 0 greater than 2. So just we are solving first one. So first is condition giving z or lies between 0 and 1. Z lies between 0 and 1. So we have given this series, that is 1 upon z square minus 3z plus 2, and we can also write it in the factor voice. We can also write it z minus 1, z minus 2. When you will open it, then you will get the same thing, this one. Okay, so now it is 1 upon, so now we will do partial fraction. Now doing partial fraction. So 1 upon z minus 1, 1 upon z minus 1, z minus 2 is equal to a upon z minus 1 plus b upon z minus 2. Okay, so by applying shortcut method, a is equal to z is equal to 1, we will put here 1 minus 2 is minus 1, means z is equal to minus 1, and b is equal to z is equal to 2, we will put here 2 minus 1 1, b is equal to 1 minus 1 1. Minus 1 and 1. Okay, yeah, so now we will put it here. This will be, I'm not writing a complete again, I will write 1 upon z minus 1, so I'm not doing all of that. I'm just writing here minus 1 here. In place of this it will be 1. It is z minus 2. Right, it is z minus 2. So now what I will do is, see, here should be 1, so that हम बाइनोमियल एक्सपेंशन तभी लगा सकते हैं जब यहाँ पे 1 होगा. सो यहाँ पे नाउ वी कैन राइट z minus 1 plus 1 into 1 upon 2. I am taking common, so 2 has been taken common. Has been taken common. 2 z by 2 minus 1, z by 2 minus 1. Okay, yeah. So now if I am changing the sign, and I can also write it minus 1 upon 1 minus z, and this can be written as minus 1 by 2 z by 2 minus 1, 1 minus z by 2, 1 minus z by 2 minus 1. Okay, yeah. So now applying binomial expansion. Okay, so what was binomial expansion? 1 plus x to the power minus 1, it is equal to 1 plus x square minus x cube plus x4 and here 1 minus x to the power minus 1 is equal to 1 plus x square plus y square plus x cube sorry, plus x square plus x cube. Here will be also plus x only, plus x cube, and that is. So remember, अगर यहाँ पे प्लस साइन होता तो हम ऐसे लिखते, बट शी here it is minus here. Okay, so what we have is minus 1 minus z, this minus 1 by 2 1 minus z by 2 inverse. So what we have here minus, then it will be opposite of it. Okay, here it plus minus क्योंकि मैं यहाँ पे h लगाना भूल गया था. So now what now simply putting on this expansion only. Here is minus, so it will be just positive sign all. So minus 1 1 plus z squared plus z cube and so on, minus 1 by 2. So minus 1 by 2 minus 1, it is just something like this. So it will be 1 plus z by 2 plus z square by 4 plus z cube by 16. Okay, yeah. So now just for more precise values, so remember one thing again. Okay, so this will be our expansion. According to Taylor, according to this series, according to condition which is given, 0 lies mod of z between 1. Okay, now looking towards second example, which is this one. Mod of z is less than 2. Mod of z is less than 2. Remember, if mod of z is less than 2, then 1 upon, if mod of z is less than 2, then mod of z by 2 will be less than 1. अब यहाँ पे मैं यह बताने की कोशिश कर रहा हूँ that अभी हम mod of z कॉमन लेंगे, so that it can be less than 1, then only we can applying binomial expansion theorem. Okay, yeah. So let's solve. This is our equation given. We have already found the value of a and b. I will find the value of a and b. A value is minus 1 upon z minus 1. Minus 2 I am writing, and z minus, so 2 minus z. I have just changed here z minus 2, so I have written 2 आगे and z पीछे. So that's why I have done this 2 minus z. So here also minus. So now see. Now हमें यहाँ पे किसी भी तरह के 1 बनाना है. ओके, so what I will do, I will take z common, and यहाँ पे हमें किसी भी तरीके से 1 लाना है, तो I will take here 2 common. Okay, so after taking common, minus 1 upon z has been taken common, then 1 minus 1 by z, right? Minus 1, 2 has been taken common, then 1 minus z by 2, right? So now I can write it something like this: minus 1 upon z, 1 minus 1 by z minus 1, minus 1 by 2, 1 minus z by 2 inverse. So now simply we will apply binomial expansion. From binomial expansion I'm just doing directly. It is z, okay, it is z. So minus 1 upon z, it is minus, all will be in positive, 1 plus 1 by z plus 1 upon z square and all, and minus 1 by 2, 1 plus z by 2 plus z square by 4 plus z cube by 8 and so on. So this is our expansion according to second condition. Now let's move on to the third condition. What is third condition? Third condition is third condition is mod of z is less than 2, mod of z is greater than 2, mod of z is greater than 2. Okay, so as we have given equation, let me write it. F of z is equal to minus 1 by z minus 1 plus 1 by 2 minus z, right? 1 by z minus 2, that is 1 here. 2 by क्या equation, z minus 2, right? Z minus 2. See, this is it. Means 1 will be greater than, sorry, means mod of z will be mod of z upon 2 greater than 1. It should be less than 1, okay? 2 upon z 1. One should be less than 1. Sorry, what I'm saying. So same we will do here also. This is very boring here. So again I'll do same thing. I will take here what common. I will take here. I'll to make here z minus 1 minus z. So I'll do that. I'll take here z common. So minus 1 upon minus 1 plus 1. So I'll take here z common. Then sorry, this is minus 1 only. We'll take z common. Then 1 minus 1 by z. Okay, and minus here 1 upon 2 minus z. I'm taking 2 common. So 1 minus z by 2. Okay, so same thing, minus 1 upon z. This will be as it is, minus 1 upon z, minus 1 by 2, 1 minus z upon 2, minus 1. Got it? So again I will use your binomial expansion and we will get the answer. So I'm doing the fourth one. Fourth is z plus 1 is lies between 0 and 2. Okay, so let me write the equation. F of z is minus 1 upon z minus 1 plus 1 upon z minus 2, z minus 2, z minus 2. Okay, so see this, z minus 1 is equal to z plus 1 is equal to t. We have let means z is equal to t minus 1, right? So I'm just replacing by t minus 1 to z. So t minus 1 I'm just replacing by it. So minus 1 upon t minus 1 means t minus 2 plus 1 upon t minus 1 minus 2, t minus 1 minus 2 minus 3, t minus 3. Okay, t minus 3. So now here what should we do, as this was our equation, so I'm just replacing it by t means 0 less than t less than 2 means here mod of t is less than 2, sorry, mod of t upon 2 less than 1. So f of t, now I'll take what common, I will take 2 common, so minus 1 upon 2, so taken common 2, और अगर 2 हम आगे करें तो माइनस चिन्ह प्लस हो जाएगा, सो मीन्स 1 माइनस टी बाई 2. ओके, यहाँ पे भी अगर सेम चीज़ हम करें तो माइनस 1 अपॉन बट विल टेक कॉमन हियर इज 3, so 3 means 1 minus t by 3. Okay, so same thing, now just 1 by 2 and 1 minus t by 2 minus 1 by 3, 1 minus t by 3 minus 1. Now simply applying the binomial theorem. So 1 by 2, what was binomial theorem? Simply minus here, minus is also here. Then what I will do is just add, just simple. So just 1 plus t by 2 plus t square by 4 plus t cube by 8 and minus 1 by 3, 1 plus t square by 9 plus t cube by 27 and double, and here what we have let t is equal to z plus 1. So just simply now we will replace it t by z plus 1. Okay, so now we can replace, although I'm not doing this, so this will be our expansion. So we have done 4 conditions was given and we have solved 4 times. Now let's see this another example. So let's see the example number 2. Again we have to expand the series, and the series is given f of z is equal to z square minus 4 upon z plus 1 z plus 4. And conditions are given. First, mod of z less than 1. Second, 1 is less than mod of z is less than 4. Third, mod of z is greater than 4. Okay, so now see, this is given. It can be challenging for us. See, after solving this I can write it z square minus 4. I'm just solving it. I can write it z square plus 5z plus 4, right? Z square plus 5z plus 4. Okay, so now we know that I cannot do partial fraction because here is 2 terms. I cannot do this directly. So what I will do is I'll divide it by this. Then after, let's do this. Firstly, z square plus 5z plus 4 is divided by z square minus 4. Okay, so now if we will see, then it will divide by one time. So z square plus 5z plus 4. Doing subtracting, so this z should z cancel. It will be minus 5z minus 4 means minus 8 minus 5z minus 8. ओके, सो अभी हम अगर हम 3 को अगर हम 17 से डिवाइड करें, आई एम डिवाइडिंग 17 by 3. So what we'll do, we write what we do 3 5s are 15 2. So how we write 3 5 upon 2, right? Sorry. How we write it? Just how we write? We write. Sorry. We write 5 minus 2 by 3, right? So how will I write 5 plus 2 by 3? 5 plus 2 by 3, right? Just forget it. You should do this in 7th class. Now I'm not able to remember. Okay, so 5 plus 2 by 3. Now if we will solve it, then 5 दिया 15 plus 2 17/3, right? We will get this. Now same thing we will do here. So how can we write it? Something like this, right? So 1 minus I'm taking here minus common, that's why. Okay, 1 minus 5z plus 8 upon this z square plus 5z plus 4, right? So now I can apply partial fraction because यहाँ पे power 2 थी, so we cannot apply in the power of 2. If we will expand it, then it can be written as z minus 2 z plus 2. Okay, so that's why we have to make it in power 1. So now here z is single, the power of z is 1, so I can now 5z plus 8 upon 5z plus 8 upon 5z plus 8 upon z square plus 5z plus 4. So one more thing, that this can be written again z plus 1 z minus 4. It can be written as z plus 1 and z plus 4. So is equal to 1 upon z plus 1, sorry, a upon z plus 1 plus b upon z plus 4. Okay, yeah. So now here we have to find the value of a. A is equal to z is equal to minus 1. I am putting here z is equal to minus 1. Here minus 1 means 3. Will 3 here minus 1 minus 5 plus 8 minus 3. 3 upon 3. So 3 upon 3 is 1 only. A is equal to 1. And now b is equal to z is equal to minus 4. I am putting here minus 4 minus 3. 5 को 20 minus 20 plus 8 means minus 12. Minus 12/3 means minus 4. Here will be what? Here will be minus 4. Okay, so I have found the value of a and b. Now putting in this, so 1 upon z plus 1 plus b upon 4 upon z plus 4. Okay, 4 upon z plus 4, not 4 minus 4 yaar, minus 4. Okay, 1 is as it is. How can we forget this? 1 is as it is. So now what we will do here is, firstly we are solving now. Here we have to make Here we have to make 1. So what we will do is again, let me write it everything again. So it will be 1 upon z plus 1 minus 4 upon 4 minus 4 upon 4. If I am taking this like this, minus 1 upon z upon 4, so I can write here positive, right? So 4 to 4 will be cancelled, and now I can write it minus 1 minus z plus 1 minus means inverse plus 1 minus z upon 4 inverse, it is z plus 1. Now simple binomial expansion, right? So 1 minus z plus 1 expansion will be 1 minus z plus z square plus minus z cube, and same here, plus here is minus, so 1 minus z by 4 plus all plus z square by 16 plus z cube by 64. Okay, yeah, so okay, this will be our expansion. I am solving here. First of all, mod of z is less than 1. Okay, this was first part. Mod of z is less than 1. Now second equation is z lies between 1 and 4. So let's solve it. So second equation is 1 z lies between 1 and 4. Okay, so our equation will be same as this. What was the equation? This was something like this: 1 minus f of z was 1 minus 1 upon z plus 1 minus 4 upon z plus 4 minus 4 upon z plus 4 z plus 4. Okay, so yeah, see here, firstly this, if so 1 upon mod of z will be less than 1, and second thing, that mod of z upon 4 will be less than 1. So I'm just trying to show here that here we will take 4 common, here 1, here z, so 1 minus 1 z have taken common, so 1 plus 1 by z minus 4 z minus 4 I have taken common, so आगे 1 आना चाहिए ना, तो हम माइनस माइनस कॉमन ले लेंगे. So 4 I have taken common, 4, so here will be 1 minus z by 4. Okay, so 4 to 4 cancel, so 1 plus 1 by z, so 1 minus 1 upon z, 1 plus 1 by z inverse plus 1 minus z by 4. Minus. Now simply applying binomial expansion, camera is not able to focus, I don't know why. Now simply applying binomial expansion, so binomial expansion, so here is plus, then 1 minus 1 upon z 1 plus 1 by z minus 1 upon z square plus 1 upon z cube and so on, plus 1 minus z by 4 plus z square by 16. So here will be all positive, plus z cube by 64. Okay, so this is our expansion. Now same goes with x3 also. So that's all about what are we discussing. We were discussing about Lorentz series. Okay, so now we will discuss about singularities. So like singularity, so classification of singularity, classification of singularity. Okay, so first part comes zero of function. Let fz function is defined on a domain D if a point domain D if a point A belongs to domain means D such that f of A is equal to 0, then A is said to be a zero function. Then A is said to be a zero function. And so what basically he is saying, f of z function is defined on a domain D. Okay, if a point A belongs to D such that f of A is equal to 0, then A is said to be zero function. Okay, let's discuss the example because हम सब example से ही समझते हैं. So f z is equal to z square upon z minus 1. So we know that z minus 1 means z is equal to 1. So it is a zero function. तो जीरो फंक्शन बेसिकली जीरो फंक्शन मतलब क्या होता है? जीरो फंक्शन मतलब होता है कि वहाँ पे अगर हम ये वैल्यू रख दें तो वो फंक्शन जीरो हो जाएगा. दैट इज जीरो फंक्शन. नाउ वी हैव f of z is equal to sin z means z is equal to n pi. Okay, yeah. So now second thing comes order of zero. Okay, so order of zero. So what is order of zero? Let z is equal to a is a 0 of f z. Let z is equal to a is a 0 of f z, then f of a, is equal to 0, then f dash a is equal to f of a 0 and f double dash a So So basically main characteristics, we will differentiate as much time till then we didn't receive derivative a constant value. Okay, so now let's see the example on order of zeros. So example, we have f of z is equal to z square. So z is equal to 0, so f of 0 is equal to 0. F dash z is equal to 2z. Again we will put f of dash 0, then again we will receive 0. F double dash z, it will be 2. So now this is order of 0. Okay, so I hope you have understood what I was trying to teach you. So now we will see another topic, that is regular point. Now we will see is regular point. So now regular point. What is regular point? Like we can write a point z is equal to a is called regular point. For is called regular point. Here will be regular point for f of z if f is analytic, if f is analytic at a. So example, f of z is equal to e to the power z. A belongs to C, is analytic if f of z is entire function, then every complex number is regular point. For function. So basically regular points are which are analytic at a. I have told you that which type of functions are analytic. It's very simple. So now we will see a regular point is done. Now we will see singular point. I'm not sure with these spellings, please make sure from your side. Okay, so singular points, just opposite. I can also write just opposite of regular point. Regular point means where the function will be not analytic, that will be a singular point. Let's see theoretically. A point z is equal to a. A point z is equal to a is called singular point of fz is called singular point of fz. If fz is not analytic at A. For example, f of z is equal to 1 upon z is not analytic at z is equal to 0. At z is equal to 0. 0 is a singular point. Z is equal to 0 is a singular point. So if it is not analytic at z is equal to 0, then it is a singular point. It's very simple. Singular point. So there are some types of singularities. There are some types. Isolated singularity, isolated singularity, and second one is non-isolated singularity. Now इसके भी टाइप्स होते हैं. आइसोलेटेड सिंगुलरिटी के फर्स्ट टाइप इज रिमूवेबल singularity. Second one is pole singularity. Third one is essential singularity. Okay, then let's discuss the another topic, residue at infinity. Residue at infinity. Basically, statement is let fz be an analytic function. Be an analytic function in T except a1, a2, a3, an. Residue z is equal to infinity. F of z plus residue z is equal to a. F of z and f of z. Second, at infinity, residue at z is equal to infinity. F of z is equal to residue at z is equal to 0 minus 1 upon z square f 1 by 2. Okay, so see the evolution of example. Suppose f of z is given z square upon z minus 1 z minus 2. Okay, so here the singular points will be z is equal to 1 and 2. Limit, first of all, z tends to 1. I think I have told you already this, right? Z tends to 1, so I'll put here z minus 1 into z square upon z minus 1 upon z minus 2. Z minus 1 cancel. I'll put here 1 means 1 upon 1 minus 2 is minus 1 is equal to 1 minus 1. Okay, at z is equal to 1. Now z is equal to limit z tends to 2. z minus 2 z square upon z minus 1 z minus 2. So here will be 2, 4 upon 1. This will be 4. Okay. So f of z can be written as minus r1 plus r2. r1 plus r2 means minus 1 plus 4 means minus 3, right? So it is f of z. So one more topic which is remaining, that is Moreras theorem. Moreras theorem. If fz is continuous, statement is if just simple opposite of I'm not sure with this meaning, opposite of Cauchy theorem. Okay, so integration of c f z of dz, integration of c f of z dz, integration of c 3 f z dz. So wait, what I'm trying to do is, suppose we have this closed container or loop, we can say, and instead of this there is one circle, and this is passing through this. It is c1, c2, c3, c4. Then basically what he says, that all integral values will be same. Obviously, if this container is same length we are taking partially, then these all values will be same. Obviously baat hai. So statement can be written as f of z dz is equal to 0 for every closed counter or loop C in the domain D, dfz, in the domain D, the fz is analytic. fz is analytic. fz is analytic. So almost I have discussed all topics. Video length will be approximate 2.5 hours or more than this. I'm not sure that what will be length of it. So thanks for watching. You was watching Raghvendra Singh on engineering mathematics. So thank you. If I missed some topics, then I'll upload some videos on that also. Maybe I may missed some topics.